This particular panel is on deployment of AI in real-world applications where theory meets action. Now, without further ado, I'm going to invite our panelists and our moderator. May I invite Lieutenant General Rakesh Kapoor, Deputy Chief of the Army Staff, DCOAS, ISNC of the Indian Army, to kindly grace the stage. A very warm welcome to you, sir. May I invite Mr. Gokul V. Subramaniam, President of Intel India, to kindly join us on stage. And I'd like to invite Professor Madhusudan Bhaskaran, Faculty, IIT Madras, and our moderator, Professor Kamakoti, Director at IIT Madras, to also kindly join us on stage. Let's welcome them all with a huge round of applause, please. So from defense and national security to advanced computing and research, this panel is going to unpack the practical challenges and promising breakthroughs in integrating GenAI into mission-critical systems. Ladies and gentlemen, with that, I now take the privilege of requesting our moderator, Professor Kamakoti, to kindly take over. Sir.
Friends, thank you. Thank you, Ganesh, for inviting us. Today we have a government, industry, academia on stage. I think that's the role of a director, to bring all these three together. I'm very happy to be moderating this session. Thank you at the outset. Chandra Saab, Gokul and Madhu, thank you very much. So we are now in a very interesting stage in AI. What once we call as a digital divide, we are also now worried about a potential AI divide. And this AI divide can come out of four important things. One is non-availability of good human capital. Second thing is accessibility to resources. The third one is availability of resources. And the fourth one is affordability of resources. And affordability is not just cost, but other things, including energy and other considerations. So this opens up a new topic of, should we do this full AI like what other models have done, the full model, where we have these domain-specific requirements. So should we shoot that mosquito with a revolver, and will that revolver really shoot that mosquito? It's a bigger question that we want to put in front of the three panelists here. So we start off with the notion of having a domain-specific LLMs, which in some essence BharatGen is trying to capture. Right. So I'll start with round one. General Saab, first and foremost, on behalf of this entire audience, we congratulate the Indian Army for a very, very successful Operation Sindoor. So we'd like to hear from you, General Saab. What is GenAI for Army's modernization and digital transformation efforts? What does it mean?
Firstly, thank you very much for inviting me here. And I really consider it a privilege to get this opportunity to share some of my thoughts with all of you. And particularly to be sharing stage with such illustrious panelists. You ask a very significant question, how does the Army look at AI, and how do we look at its employment? Firstly, I'd just like to take a minute and describe what is the character of modern conflict. How is modern conflict going to manifest? And we've just had a glimpse of it on our doorsteps last month. Firstly, if you see conflict in four quadrants: contact, kinetic; non-contact, non-kinetic; non-contact, kinetic; and contact, non-kinetic, if you draw four quadrants here. When I grew up in the Army, our focus was essentially on contact, kinetic. It was closing in with the enemy, and how you engaged. You used to do physical maneuvers, and you had to ensure that your will prevailed over the adversary. But over the past years, what we've seen, that the share of contact kinetic is gradually reducing. I cannot, put a figure as to how much it has reduced or how much it has increased. But a very large share of conflict is in the non-contact, non-kinetic mode, non-contact, kinetic mode. That is really on the exponential rise. So what is the inference that we draw from it? The inference that we draw from him is, on the battlefield today, technology is a key driver. Because you can only do this if you have technology. And the other inference that you derive from this is that, in fact, technology has become a deterrent. The concept of deterrence has changed. Technology itself is a deterrent. Now, coming to the basic question that you asked me as to how do we look at AI. If you have to execute non-contact, non-kinetic, you want accuracy on the battlefield, you want persistent surveillance on the battlefield, there are no second places on the battlefield. There's something called, there are no runners-up in war, that they say. You either win or you're vanquished. So, the battlefield itself is becoming intelligentized. And there's a huge amount of information overload that is taking place on commanders. The sensor-to-shooter link has to be very robust, and the time span has to be very little. So what do you need? You need computing on the edge. You need deterministic models which give the commander immediate answers. You need accurate locations. So if all this is going to happen, also you need robust supply chains. If I expend a piece of ammunition, intelligently my system must tell me that I'm deficient of this ammunition, my supply chain should kick in, and automatically that ammunition must reach. So which is that big, item in town which can get me all that? That is all about artificial intelligence. And, that is how it all happens. But while I would say this, there are a huge amount of ethical issues to this when it comes to, when you come from mill to mill perspective. So whatever the armed forces does as far as artificial intelligence is concerned, the employment of artificial intelligence for precision guidance, for precision targeting, that responsible employment of artificial intelligence is very important. We need to humanize artificial intelligence. Therefore, the man in the loop will still be important because decisions will still have to be taken in a very ethical manner. And particularly in Indian conditions, where our employment of armed forces is done in a very responsible manner, we calibrate the quantum of force that we use as per requirement. There's just ad bellum and there is calibration of that. So therefore, the human dimension is very important. I'll just take half a second more and while I talk about this, there is a huge challenge or a huge requirement that we face, because all this entails data. Today we have structured data, we've got unstructured data. So this is where we are engaging with multiple partners, with the academia, the industry, different players, to get all those data sets right. And how do we bring it into our systems? Thank you, sir.
Thank you, General. I think you have set the stage for this entire panel now. So let me go to Gokul from Intel. So what's the role of CPUs in inferencing?
It was like an interview question, but I would try to reframe that slightly.
There are students whom you will interview,
I know,
so you
I'm
can
sure.
give the answers.
I think it's fair to say, if you want to democratize AI, and we talked enough today morning and even in the previous session about AI being everywhere and how can it reach everyone. I think it's fair to say that it starts with computing. Clearly, we've seen, the cost of compute is not a one-size-fits-all. And we've seen that in our roads. We don't have the most expensive cars being driven all the time. It's all kinds of shapes, sizes, engine sizes, and the need of the passenger and others. So in that sense, CPU still plays a pretty fundamental role. In fact, even more, and it was great to hear the general talk about edge computing and the data integrity, and in terms of multiple data coming together, a lot of that aspect is heavily orchestrated by CPUs. And CPUs are no longer just deployed there and sitting and being idle, do a number of things. And the advancements on the compute side is far and bigger. And in enterprise AI, in edge computing, clearly we've done a whole bunch of things to democratize and bring AI-driven optimizations on CPUs. Be it matrix multiplication extensions, be it for vector processing, and I don't need to talk about that to Professor Kamakoti. He is a pioneer in one of those areas. But the ability to do a lot of that calculation at a lower power, faster, without using too many of the sophisticated barriers that are needed to deploy, starts with the CPU. And the other important aspect is also having the ability to have this compute in various sizes, be it at the end user side, and we heard a little bit about agent and agentic approach, be it actually on a laptop or on a phone, whatever that might be, to an edge where you may be getting feeds of hundreds of cameras coming in for you to be able to process that with image processing, with the kind of computer vision data sets. These are very critical aspects for the processing capability that we've made advancements in the CPU. So CPU still continues to be at the central, and I can go hours together to answer that question, but I will pause with that.
Thank you, Gokul. Madhu, I have myself forwarded around 100 internship applications this last 2 weeks. So you've been working with training models on using GPUs, training models using CPUs, inferencing using CPUs, all varieties of things at Pravatak. Now, can you just tell me, again, whenever a project comes, you say that there is a lack of skilled manpower in this particular area. So what would be the skilling requirement in general in GenAI? So there are a lot of students who can just prepare themselves for the AI revolution.
Thank you. So when we talk about training a model, the first question that comes across is GPU. I do not have GPU. So, as Professor Kamakoti rightly said, do we want to kill a fly with a revolver? And you miss most of the time. Perfectly said. So domains, we have been building solutions which are extremely domain specific. And the moment I say domain specific, adaptability is something which is definitely possible. I can give you examples between military and civil applications. You look at a distributed small model which can be used in a disaster management scenario. You have a natural calamity and I build a model which is distributed among very low powered devices. It could be CPUs, it could be XPUs. Take the same scenario. Can it be adapted to the mill application? Definitely possible. So, though I am talking about domain specific, the data becomes very important. The end goal becomes very important. I can build a solution using CPU, inferencing, very highly domain specific model, which can solve a partial differential equation, an ordinary differential equation. Now the same model can be adapted for a drone to be autonomous. That means, you talk about fire and forget. You have drones which can just be, which can take decisions on its own. Now, the moment we talk of drones, again, energy becomes a major constraint. I cannot have fast CPUs. Then CPU itself becomes a constraint. In this scenario, can we distribute? We are talking about swarms. And when we are talking about swarm drones, how do they maintain radio silence? Right? We are talking of 90% radio silence, maybe 10% they switch on, communicate with each other. What happens if a couple of drones become, if they fall down? In that case, the same scenario it also applies to your natural calamity. So, we firmly believe that do not shoot a fly with a revolver. Focus on domain-specific language models which can adapt across multiple domains. That would be my take, sir.
So, General Saab, so we'll now come to the affordability part. So, two questions I have. One is, will GenAI reduce cost of operations in the long run? Number one. Number two is also very happy to announce to all of you that today BharatGen is signing up with Indian Army and we are going to develop a new model called Pragya. Pragya means wisdom. And I also request General Saab to talk a little bit more about Pragya and your expectations. Thank you.
Firstly, I need to thank all of you for this Pragyan initiative. I need to thank you, Professor Kamakoti, Professor Madhu, and Professor Ganesh. We had a huge issue of data overload and info overload, and we needed to bring our decision making more precise. We had ISR data, we had logistics data, we had intelligence data, and as you are all aware, decision making has to be fast because there are, you could be targeted if you don't target first. And so the first edition of Pragyan is, on the starting blocks. And I totally endorse what Professor Madhu has said. It could be a LLM, created for some civilian use. It could be an SLM created for civilian use. There is huge amount of opportunity to evolve it, modify it for military uses. We will bring our own data, and the tweaking can constantly be done. So therefore, I'll urge everybody in this house, whoever is working on this, to please come and engage with us. We've also in the Army opened an AI incubation center in Bangalore. And we've opened it in a commercial space. We've also, with the indulgence of Professor Kamakoti, we are opening an Army IIT research center in IIT Chennai. There is opportunity to come and do that there. And other IITs also, I'll request you, please come and engage. So whatever you're doing, we would like to learn from it. We would like to modify it to our requirements. And one of the byproducts of your creations can be put to military use. Now, conflicts are expensive commodities. I don't think I can put a finger on the fact that, whether it will reduce the cost of conflict. But what it will certainly do is, it will improve our ability to take decisions. It will improve our ability to do precision targeting. It will reduce collateral damage. It will ensure a very responsive supply chain. It will ensure early diagnostics for medical casualties. And with the support of the nation, your armed forces will be better ready and better equipped to bring victory back to India.
Sorry, Kalista has left, Ganesh has left, but I wanted to ask this question in front of NVIDIA to Intel. Okay. So, Gokul, what will happen if one don't have access to GPUs? So, no GPUs. So, what will your XPUs? You have NPUs, VPUs, DPUs in addition to CPUs. I also want you to comment upon the energy crisis that eventually we are leading to. How can CPUs and Intel efforts can solve that.
Absolutely.
Just before Gokul starts, we as architects were very, very disappointed when, students even did not even come for a computer architecture elective. Now days of architecture are coming back thanks to the energy consumptions of GPU. Now I want you to elucidate and motivate more students to take architecture.
Absolutely. In fact, without I think Professor Madhusudan talked about it, access is the most important thing for learning. And we talked about personalized tutoring and teaching and all of that stuff in the earlier session. But for a budding engineer, having access to compute to learn AI is important. And compute come in many shades. So back to the main question, right? It's about what compute is required and how you can abstract that out in a way that you are able to write once and you can have it running in various forms. So, going back to not just taking general purpose processors, but taking CPUs, GPUs, and NPUs and making sure that they are tailor-made and have accelerators that are more native to the architecture and abstracts it out is one of the key things. And one of the things that we've been doing also on the Xeon side, on the server side, is having these extensions that really allows complex mathematical functions to be done, be it financial, be it scientific calculation, be it weather-related, be it vision-related, things like that with our AVX extension. Another example is all the matrix multiplication extensions that are there for a whole lot of computation that is involved. Think of 8 layers of 2-dimensional matrix that you can just do it in one instruction cycle. Things of that sort that are very fundamental to the computer architecture. Those capabilities are there without having to really burn a lot of power and having to give you an engine that is way more than what you need. Now, in terms of just compute capability, there is this XPU terminology that is going around. You have workloads that are bursty. You can use a CPU for it. There are workloads where you have a lot of the media, where you need video, imaging, and codec and display related stuff. You use the integrated GPU that's available in the processor. And then if you have to run something sustained in the background, be it for summarization, be it for something that you want to keep running to gather that intelligence about you and your data on the edge, you have the NPU for it. And all of these are not discrete accelerators. They are packed into one SoC with open API architecture that you can write once so that underneath it gets orchestrated to the right XPU. So those are the capabilities that are available. And it is probably one of the most exciting times because every laptop that you use as an engineer has the ability. We've already deployed more than 40 million, 50 million AI PCs. By end of this year, there'll be 100 million AI PCs in the world. It doesn't mean that you need an AI PC to do it. You can very well load up to 7 to 8 billion parameter models on a PC and run locally without a network, be able to do the kind of things and play around with it and learn. You can go one step ahead and be starting to use data centers and servers, which can let you go up to 20 to 30 billion parameter models. We have hundreds of these models already running and available for students to use. Do the research, understand the architecture more natively. And this is not about which processor wins. This is about what problem you want to solve in the most frugal, cost-effective way to achieve the solution. Now, going back to power and thermal, this is a big problem that is around when you run the AI workloads. And, just from 2022 to 2030, 200x is going to be the amount of power increase and the kind of carbon footprint, carbon emission that will happen. So from a sustainability standpoint, this is not, it may look very fancy now, but a lot of the next decade and the decade after, we're going to pay the price for it. And so there is a ton of opportunity in technology and innovation to actually make processors more energy efficient. Thermal solutions, this is not just only for the computer and EE engineers. There is a lot to do with materials. I think we talked about 2D materials a while ago in the previous session. There is a lot about thermal engineering, direct-to-chip cooling, how you can use some of the fundamental thermal principles to cool the chip, Liquid immersion cooling is another great place. And more importantly, and I think the theme of this is picking the right size, right? And thanks for the opportunity for setting that example up. I think it's very important for the students community too.
I think this conversation can go on for hours, but since we have very less time, now I open up for questions. Students, ask the Intel man, ask the general. Yes, madam.
The question is for the general. The spying is also going tech, and in the wake of that, and also the confidentiality. And third thing is the talent upskilling in your organization.
Ma'am, thank you very much.
I'm Swarnalatna from the Ministry of Electronics and IT. Primarily, I work in the Indian languages domain.
Thank you very much for the question. And what you said, as technology and humans have had a symbiotic relationship. So yes, as new technologies come in, there is upskilling in that, in the way you do things. Yes, espionage is also increasingly improving in capacities. I may not be able to describe as to how it all takes place, but I'm sure everybody reads about it. But what I'll really focus is on since we have a large human resource, and this human resource has to be oriented to the modern battlefield. So we have to empower them with greater amount of technology thresholds. So what we are doing is, firstly, right at the entry level, the technology threshold has improved manifold. I know I'm speaking to a very erudite crowd, which is here, IITians and everyone, and we've always revered anybody who joined the IIT. But I will also tell you today, to join the NDA, over 500,000 children apply. And the written examination from a technology perspective is so difficult because we only have to take 300. So, and that focus is maintained right there. And the academic curriculum there itself has a BTech program along with it. So some people do a BTech right there. We also have direct entry BTech schemes which are coming in, and that is this thing. Our in-service training and the multiple examination schemes that we have in service as a huge component of technology. I would say there is almost, apart from the other subjects that you do, almost 1/3 of it is just technology. And but we are application centric. We are not academic centric. We are application centric as to how do you apply it, practically apply it. And so that is one component of it. Also, we send a lot of, we do a lot of cross postings, cross staffing. We send people to IITs and all to do various technology related programs. They do research. And the good part is, I find most of it today is dual use. So what somebody like today, if you talk about drones have to be used for agriculture, drones have to be used for delivery of medicines, drones have to be used for shopping, drones have to be, and so do drones have to be used for military applications. So there is already a key in there. So we are really focusing on this, and I just wish to inform this house, the year 25-26 has been declared by the Chief of the Army Staff as the years of technology absorption. So thematically, we are also looking at technology.
General Saab, this is for you. My name is Alok Agrawal. You talked about the importance of data, and one very key or core aspect of AI development is data. I'm sure RV is sitting on really, really rich data, and the kind of data you have probably others don't have. For example, in vision, drones, all kinds of aerial vehicles would require some kind of vision models and so on. So would you be willing to offer this data out in the open, some of that? So not everything will be available, but some of that which is not sensitive could be, because not everybody may be able to participate at your incubation center to develop their models.
Mr. Alok, thank you very much, and you raised a very significant point. And if something kept me awake at night was data centricity, as to how do we bring the battlefield more intelligentized. On case-to-case basis, we can look at it. We can look at it. A certain amount, let's say, medical data, certain amount of what happens. I mean, I may not be able to, across the stream, I will not be able to tell you, yes, this I'm willing to share. But on case-to-case basis, if you send us a proposal, we'll analyze it. So keeping our confidentiality and our operational issues in mind, on case-to-case basis, we'll definitely like to take this on. Can I also take a minute, with your permission, to, since I find a very motivated and a committed audience here, I just want to say one thing. If we have to go and become leaders in artificial intelligence across the globe, there is no deficiency of human capital in our country. In fact, it is our people who are doing work overseas. There is no deficiency of human capital. The issue is we need to aggregate our efforts. All of us together need to aggregate our efforts. Like when we had the space program, we used it as a strategic project. We will send so many satellites in this, and there is no better person, because why I'm saying this is more for Professor Kamakoti. Somebody like him needs to lead this initiative. I think we need to treat artificial intelligence as a strategic initiative, where private players, government, academia, together we push this drive. And so then data sharing also becomes easier. There's some empowered body which says, okay, share this much, do not do this. This has already been developed by, let's say, a private player. Let's adopt that. Let's bring this in. This already government has done it. Let's share it with the others. So a strategic approach, an aggregated approach is required for taking artificial intelligence forward in our country. And I think we have the ability to do it. And I think together, if we put our heads together, we will possibly become world leaders in that.
So thank you, General Saab, for coming today. And again, I'm sure BharatGen and Indian Army will work together. And many of your comments we've taken note of. And certainly we'll put all our efforts to see that we are victorious. Your victory means our victory. Thank you very, very much. And Gokul, all the best for more CPUs in the AI and more NPUs in your AI. And I also am very happy to note that there are systems right from laptops to high-end servers which are now benefiting from the hyper-threadings and the vectors and the SIMD instructions that you had introduced in the past. And I'm sure a lot of work that need to be done by people who teach architecture, who teach programming today. That should be a different dimension, and I'm sure we will all work, and we'll take it as a BharatGen initiative to see that type of education goes in. And thank you, Madhu, with all your best. More and more models should come. So, and thank you all audience for being a very wonderful audience. I know it's just before termination session, the last but one session. Thank you very much.
And we thank you, Professor Kamakoti, for steering such a wonderful conversation.